to be plotting the stars based on their temperature and absolute magnitude / luminosity. So let me show you how you are going to do this. So last class, you got the spectral type, the type of star, that's fine. But we're gonna be looking at these two values, temperature and absolute magnitude. As you can see in the H&R diagram, we use it to explore and investigate the evolution of stars as they go from main sequence to giants or supergiants, and as they die either in a supernova event, which normally happens for stars that are around here. So they are very hot, very luminous, very big, of course, but they eventually run out of fuel very quickly in like 1,000,000 years or less in some cases. And when they explode into a supernova, then we have a whole different aspect of discussion, right? We have to talk about neutron stars, black holes, space and time. But the evolution of stars for a star like the sun, which is around here, it will keep, well, actually, it will evolve into a giant, not a very big one, and then it will not get into the carbon, the CNO cycle that you are discussing in the lecture. Carbon, nitrogen, oxygen. It will get into a red giant, fusing helium into carbon, and then it will die out until it becomes a white dwarf. So if you think about it, right, the sun is it's a low mass star. It's here. There are many stars in the main sequence curve, so this area, that you should find today, and then some in the supergiant, some in the giant, and you have the 4 white dwarfs that you have to also plot here. Something that many students tend to forget or not to notice is this R. Now let's make this bigger. The R value is the radius of the star. So as you expect, a white dwarf has a radius of 0.001 and 0.01, that range. So you are going to find a white, you're going to locate these white dwarfs in here. And then, well, the sun, R1, luminosity 1, it intercepts around here. And that makes sense because the temperature of the sun is around 5,800. So the sun is around here. Always try to use it as a reference when you compare it to other stars, by the way. So the luminosity go in powers of 10 respect to the luminosity of the sun. So this is 10 times the luminosity of the sun, 100 times, 1,000 times, and so on. That's why you're going to use the absolute magnitude and the temperature to do the plots. Okay. Let's go to Vega. Vega is a main sequence star. How do I know that? Vega has an absolute magnitude of 0.57, 0.6 approximately, right? And it's an A1V star. According to this table, it should have a temperature of 9,800, 9,850. Let's use 9,800. So temperature goes from lower to higher, from right to left. I'm not going to repeat this again. From right to left, you have to look at the plot. So if this is 10,000, 5,000, 6,000, 7,000, 8,000, 9,000. Oh, wait. This should be 7,500. Okay. So this is 7,500, right? 8,000, 8,500, 9,500, there it is. So this is 9,500. So it should be around here in the temperature. And the absolute magnitude was 0.57. Okay, let me mark this with a marker here. So we say around here, right? There. 0.57. If you look at the plot carefully, plus 15, plus 10, plus 5, 0. Above 0 are the negative. So the chart is sort of inverted. Why is it inverted, you're probably wondering? Because remember, the lower the magnitude, the higher the luminosity. So the luminosity goes up. So the magnitude has to go down. That's why we plot it like that. Anyway, 0.57, 5, 4, 3, 2, 1, should be around here, half of it. So let me see if I can bring a ruler here. Oh, it was here, right? Yeah, there's a line here. I will probably place it around there, right here. Straight there. So my star Vega is located at that point there. Here. All right. So that's where Vega. So Vega is still in the main sequence. But remember, the sun is here. So Vega is more luminous, around 100 times bigger, 100 times more luminous than the sun. And how much bigger is Vega than the sun? Well, look at this radius, right? Radius 1, radius 10. So this should be in between 1 and 10. I will say probably 3 to 4 times bigger than the sun, right? Because the lines have to be parallel. So a parallel line to this should be something like this, right there. So 3 times bigger. That makes sense. All right. Now you don't have to do everything I did here. You just have to plot it. So you're gonna plot all your stars in this chart today, using the temperature and using the absolute magnitude. And that's it. I want you to complete this today, all of it. I'm gonna have my dinner now. And then once you finish doing that plot, you can start answering all these questions. That's the easy part of the lab, because all these questions are based on that chart. Right?
Wait, what's the formula?
Questions about how many stars can you find in the upper main sequence, so high temperature, high luminosity, here, right? So it's just a matter of plotting the stars first.
What's the formula for the temperature?
There is no formula. You have to estimate it with the spectral class. So if you have a spectral class, in the case of Vega, A1V, A0 is 10,000. A1 is a little bit less than 10,000 because it goes from A1 to A9. A9 is 7,500. A1 is around 9,800. It's an estimate. All right. That's why you use both points. The absolute magnitude, which is accurate, is here. And the temperature. All right.
Actually,
Professor. Oh, my bad. You go.
I spoke with Richard Morris yesterday, and because I needed help with it, and he gave me that formula, like
yes, there is a formula that we use in the last lab, but if you use a formula for every star, you're gonna take till next year. It's too much. Look how many stars. So just estimate the temperature using the spectral class, because if not, yeah, there is a formula that we did in the starlight with a B minus V index.
How do you want me to? Can you tell me again how to estimate it? That's all I ask. My only question.
Yeah. So you use the spectral class and you have this temperature range. And
you mean the spectral type?
Yeah, spectral type. Well, we normally call it. This is the class and subclass. And
can you do it? Can you show me Vega? Can you just do it for Vega and then I know for the rest?
Yeah. So Vega is A1B, right? So
Vega is A1B. Okay.
Yeah. So it's an A star. right? And it's 1. So the lower the number, the closer it is to the higher temperature. It goes from A0 to A9. A0 is the hottest, A9 is the coolest.
Oh, okay. So
The same
A1.
happens with O, B, F, G, K, M. Okay, guys, if your numbers are different, that's okay, better. So then you don't have to use the numbers that I'm using. Your numbers may be different because you're using a different version of Stellarium. That's okay. It still works the same way. So, for example, the sun is a G2 star. So that's why the sun is not 6,000. The sun is 5,800 kelvins.
But wait,
right?
it goes from 0 to 9.
It goes from 0 to 9. Yes.
So zero would be the highest limit. 0 would be like 6,000.
Yeah, and 9 would be the lowest.
9 would be 4,900.
Yeah, guys, come on, don't be okay. Come on, okay. I know that you probably haven't done this in the past, so I'm gonna be patient with this. Why will you estimate 9,440 something? Look at the scale they give you. So use it. What did I say? 7,500, 8,000, 8,500, 9,000. Here, 9,500. This is 9,500. And just estimate to 9,500 if you want. I would say 9,800. So in here, all right, use the scale that they use you here. If not, you're gonna take forever to plot this. All right. And at the end of the day, it doesn't matter because you just want to find the right region. Main sequence, giant. For example, let's look at giant. Bellatrix. There you are. That's a giant. Bellatrix is a blue star, blue giant in the constellation of Orion. There. Bellatrix. So Bellatrix has a good. It has an absolute magnitude of minus 2.84 and it's a B2 star. Okay, let's do it. So Bellatrix is a B star. Highest temperature should be 28,000, B0. So B2, sorry, I have to do this. Yeah. So B2 should be around 25,000, 26,000. Okay. 20,000, 25,000, 30,000. So around this area, right? And the absolute magnitude is minus 2.84. Okay. Minus 1, minus 2, minus 3. Minus 2.84 should be around here. So where did I say it was around here? Right? 25, so we go all the way up, up. Minus 1, around here. So it's still a main sequence, but it's a giant star because look at the radius. It should be between like, oh, it's still the same size actually, around 3 times bigger than the sun. So around here, right? There. Where my arrow is pointing there. Maybe even here, this limit. All right. So that's how you locate these stars. Make sense?
Yeah.
I couldn't find
What was a good guess for Vega?
Huh?
What was a good guess for the temperature for Vega?
9,800. The nave is a giant, I believe. Let's take a look at the nave.
9,800. I remember we calculated with the formula and got like 4,200.
No way. Vega?
Yeah.
Yeah. Vega is an A star.
Then what about the second one? Maybe it was the second one.
Let's see. Yeah, Vega will be way hotter than that. That's why it's very luminous. What's the second one?
Maybe it was because we got like 4,200.
Yeah, Aldebaran. It's Aldebaran. You know why? Because Aldebaran is a red giant. So let's do Aldebaran. Aldebaran is a red giant, which has a K5. Yeah, that will be around 4,000. So if you go to K, yeah, there you are, K5. So K5 is almost in between, right? Between K0 and K9. So I would say 4,000 is a good estimate for Aldebaran.
How well do you want us to estimate?
It doesn't really matter because you're gonna use it has to be accurate, but it doesn't really matter because you're gonna use the Aldebaran, you're gonna use the temperature and the absolute magnitude to find. So Aldebaran will be around 4,000, we said, right? So all this line, and it should be a giant star. It should be around here. Let's take a look at the absolute magnitude. So you see, I use both. Minus 0.7. Minus 0.7 should be around here. Oh, there you are. Here is Aldebaran. It's a giant star. It has a cool temperature, less than the sun, but look at the radius. 1, 10 is around here, I said, right? Yeah. So it should be around 12 times, no, what 12? This is 10, I think it's 100. 30 times bigger than the sun? That's why. 30 to 40 times bigger. All right, guys.
Well, it would probably be best if we took the interval and then divided it by 9, and then like if it's like, you know,
You
if
can
it's
do
like
it like
8,
that as well. Yeah, you can do it like that. But again, that would probably take you more time. So, but that's okay. The lab is due next week. So you guys have the weekend to work on it.
Professor?
Can you sorry? Yeah.
Oh, never mind. You got you.
All right. Thanks. Professor, can you just go through all the things for Aldebaran just so I know I'm on the right track, and then that's it.
So first you have to complete this table for sure.
Yeah, just for
Mhm.
Aldebaran.
Huh?
Just for Aldebaran, the second star.
Oh, this one.
Yeah, just for Aldebaran. Yeah, like the spectral type, and then
Oh, the spectral
temperature.
type is K53.
Uh-huh.
It might be different in yours because of the different stellarium version. Temperature is 4,000. Absolute magnitude minus 0.7. And type of star, double star. Right now. Yeah.
Type of star, you just go to the first page, right, with the chart.
Yeah.
And then you said the rest of the questions are just really easy.
Yeah, once you complete the table and the chart, is really, really based on all that. Oh, by the way, question 4, you're not doing question. Oh, wait, question 4 again? No, question 2. You guys are not doing question 2, okay?
Okay.
All right, guys. So on Monday, we're gonna keep working on this. On Monday, we have to work on the questions because that's it. And then on next Wednesday, in a week from now, we're gonna watch the video on black holes. And that's gonna be the assignment for the spring break. You have to have a video outline by the 29th. Because on the 29th, we have to do, on this week, we're gonna do one lab, and then the 31st, there is no lab, but you have to be here because I'm gonna give you instructions. Actually, you probably don't have to be here. I might give you the instructions this day. Because you know what? This day, at this time approximately, I have to be in the airport. So I might not be able to, I might just to be able to like just send you guys an email just to update you, but there's gonna be instructions for the research lab. You guys are gonna do an internet paper lab. But guess what? You're gonna have 1 week, 2 weeks to do that. Okay? So I will be working on that during the free time I have. All right. Yeah, it's time for me to have some relax. So I need to, so I'm gonna be traveling that way. I selected that way because that's when we are off in the school. So, all right.
Professor?
Yeah.
I wasn't here last class.
Yeah. So you're gonna have to paddle from the very beginning. You have
Okay.
to complete the table.
Professor, this is Itana. Can we have office hour on the weekend?
Okay, so tomorrow I'm going out for sure because it's warm. I'm gonna be honest. The 12th as well. It's cold on the weekend, right? So yeah, maybe.
Yeah.
13 and 14. Not the 14 because I'm tutoring that day. Yeah, I can probably do it a little bit on the 13th, but in the afternoon. Only for half an hour though.
Saturday?
Yeah, Saturday the 13th.
Okay.
But okay. you need to try and do the table. I'm pretty sure I've been very clear with that. At least try to don't start from zero though, because you're gonna have very little time to complete the lab though.
Okay.
Okay, try to do so then we can finish the lab on that day then.
Okay.
Don't finish the table and try to plot the points.
Okay.
Okay.
Yeah.
Who else is having issues with this, by the way? Be honest, because I need to know. So that
Wait.
you're good?
I'm good, I think. Yeah, with the Aldebaran thing, I mean, I think I got it all right. Wait, Aldebaran was a what type of star was it?
Giant. Hey, double star.
Okay.
Jennifer, you should be fine. Maria, you think you Sarah, you should be fine. Tomas, what about you?
What do you mean?
Are you gonna be okay? I mean, you're gonna start
To
from
do
this.
this?
Huh?
The table is like the first part of the lab, right? So I just fill out the table and then do the questions.
No. Fill up the table, plot the stars, and then do the questions. It's a long lab.
Oh, okay. I should be okay. Till when does it do?
Might make it due on the 16th.
I should be okay by
17th.
then.
It should be due the 17th because we're gonna be working on this lab on Monday as well.
Okay.
Oh, yeah, I'll do it tomorrow, and then if I have questions, I'll ask you on Monday.
Yeah, I think that should be okay for you guys. Another thing, if you guys are getting the vaccine, you have to let me know because I'm giving considerations because I know it's a strong vaccine, so you might be knocked down for a couple of days, okay?
Yeah, one of my friends just got it and he was like out for a couple days. He couldn't do
Yeah, so you
anything.
have to let me know. Don't just assume that we know, so just let us know, okay? For lecture as well.
Professor, I have a question. Hello?
Yeah.
So when we're plotting, so like the absolute magnitude, how like what would you consider like negative like 0.7 or 0.8?
So as you go above zero is the negative. So that's,
Mhm.
you see, this is -1, -2, -3, -4.
Oh,
So you have to estimate a point here in between, right?
okay, got you. Because I was wondering. All right, but now I know. Thank you.
Okay. Kimura, you are fine, right? You said that you were fine. Jennifer, I think you are fine. All right, Maria and Sarah, you guys are working on it, right?
Wait, Professor, I think for this lab, I think it's like we're like really behind compared to the lecture because he saw this lab. Richard saw this lab